Okay, in this video we're going to go through the complete process of constructing a confidence interval for the mean, otherwise known as a t-interval. Here's an example question. A research study at the University of Kentucky on teens and social media sampled 500 teenagers. Those 500 spent an average of 7.8 hours a day on social media with a standard deviation of 2.2 hours. An important thing to note is that these are possible to know. We don't need to assume that population parameters anymore. We know that our sample was 7.8 mean and our standard deviation was 2.2, and we want to construct a 90% confidence interval. I like little memory tricks because I still remember the ones I learned in high school about 70 years ago. So I like to use this. I like to pronounce it peachy, P-I-C-C-I, which is going to help me know the steps that I'm going to take to create a confidence interval for the mean. So I'm going to combine the first P and the I, and I'm going to write out in sentences the parameter that I'm trying to estimate in the interval that I'm going to use to do it. So that's for parameter and interval. The first C is for the conditions, because we have to check that certain conditions have been met, and I'm going to use sentences to write to check those conditions. The next C is for calculate. I'm going to actually do the math. I'm going to find the numbers and find, the left and right endpoints, point A and point B, and then I'm going to interpret my interval again in context. All right, there's a lot of writing, a lot of sentences for a math problem. I understand that if that causes you pain, but we just have to work through that pain together. So here I just restated the question, and we're going to work through these steps. All right, just three numbers go into three numbers I have to be given. The mean, actually four numbers. The mean, the standard deviation, the sample size, and the confidence level. Okay, so let's start with the first PI. That's what interval am I going to use, and what parameter am I trying to estimate. So this could have a variety of wordings, but this is one that would work. I will use a t-interval to estimate the mean time spent on social media in hours per day for all Kentucky teens. Now, if you felt the pain, if you felt like, give me a break, that this is a boring long sentence, I understand. You have to fight through that. You have to write a sentence. You cannot just cheat your way through this information. Write a sentence. You can do that. Okay. So some things need to be true. Some conditions need to be met before I can proceed. All right. To sum them up, we need random, normal, and independent. So the sample was chosen randomly. With an SRS, so we can just say it's chosen randomly. And again, there are many different wordings you can use. And was large enough to meet the normal condition. And then maybe specifically 500. So we have random, normal, and independent. That takes care of random and normal. And then we need to check and see independence. So since there are over 5,000 teens, which just means we did not choose more than 10% in Kentucky, our independence, let me actually change that, in Kentucky, we met the 10% condition. Sometimes those are hard. We know what we need to check. We need to have at least 30. We need to have no more than 10%. And we need an SRS. And sometimes it's hard to put those eloquently into sentences. And we'll work on that. And I'll work on that, make that a little less awkward for future examples. But that's, make them sentences. Don't just write random check, normal check, independent check. Explain why those things were met in a sentence, maybe better than mine. Anyway, conditions are met. So we have peachy, P-I-C-Z-I. We are to the calculations part. All right, so really, the math becomes a relatively small amount of the work you need to do. A confidence interval is the statistic plus or minus the critical value times the standard error. So we're just going to fill in our numbers. Our statistic, our average, it's going to be the center of this little window we're creating, is 7.8 plus or minus critical value. All right, so we had a sample size of 500. The critical value is going to be from a chart like the one in the back of the book or on your formula sheet. This one I just got online. You need to go, we're doing a 90% interval. So this is two-sided. Don't worry about the one-sided for now. We need to find the proper line on this column, this 90% column. Remember, you have one less than your sample size. So technically I have 499 degrees of freedom. On this particular chart, way down here at the bottom, you can see how it starts to skip around. And I need to use the 120 line. All right, I can't use the infinite line, even though the numbers are basically the same. But 499, the best I can do is 120 from this particular chart. So the 90 column and the 120 intersect at 1.658. So back over here. Critical value, 1.658. Standard error. Okay, a standard error is the adjusted standard deviation, in this case with a sample size of 500. So the standard deviation of my sample was 2.2 over the square root of 500. All right, so I encourage you to pause and work out these numbers for practice. I'm going to pause for the sake of time and work them out and be right back. Okay, so here you can see what I input in my calculator, 7.8 plus and minus 1.658 times 2.2 over the square root of 500. I did the minus version, I did the plus version, and you can round these to whatever accuracy applies to the problem. I'm going to call it 7.64 to 7.96. 7.64 to 7.96. All right, so with a sample size of 500, we can get a pretty narrow window. And we also have just 90% confidence, so that also contributes to the narrowness of this window. But we can see that it's somewhere in the upper half of the sevens, and now all that's left is to interpret. All right, so this is that famous sentence that you need to have committed to memory. I am 90%. Usually that's going to be 95, but there's no reason we can't do 90. This question asked for 90. I am 90% confident that the interval 7.64 to 7.96 captures the true mean, now comes the context. Mean what? That's the mean number of hours spent on social media by Kentucky teens. All right, you don't, I mean, I abbreviated Kentucky and teens into teens from teenagers, but you don't want to shorten that too much. You want to write it out. Okay, so like I said, the math itself was a relatively small amount here. The naming what interval you're going to do, naming the parameter, naming the conditions, interpreting the interval, that's the majority of the work. But this example is one all the way through, one solid good t interval, and you should be able to do this when I see you in class. Young out.